Hi, folks, welcome back. I'm about a month late to this paper, Recursive Language Models. I know it says over here it's from Jan 28th. That is V2 of the paper. It originally came out on the last day of 2025. It made a splash because many people interpreted this as being the solution to the problem of limited context windows. In that, here was a technique that could take LLMs and scale them to infinite context lengths. And it does do that, but it is a technique on top of the LLM. So it still treats the LLM as a black box, and then it does some agentic behavior and prompting on top of the LLMs to be able to process very large contexts that are much, much larger than the 500K or million token long context windows we see in frontier models today. Let's get right into how the technique works because it really is a very simple and elegant technique if you look at it. They do nod to agentic search, which is a technique that was pioneered by coding agents like Claude Code, and they eschewed that instead of using the standard embedding and RAG techniques. So the basic idea is really very simple. Say you have a very long context, say it's 5 million or 10 million tokens. The way you solve a question or a problem that asks something about that context is that you treat it as a coding problem. And once you've framed it as a coding problem, you then give it to the LLM to solve as a coding problem and iterate on it. So it is like agentic search over a very large context. So, as they say over here, they treat the prompt, the context, as part of the environment. They convert the large context as simply a variable, and this is a variable in a Python REPL. And you tell the LLM, here's a Python REPL. There's a variable called context that contains a very large context, and your job is to now write code to peek and poke at this variable to solve the question. And then you get into this agentic loop where the LLM writes out some code to examine this context variable. Maybe it's just a string, so maybe it's starting out with some regular expression searches or string searches. Maybe it has some structure. Maybe it is a list or a dictionary. And so it will emit code to look at parts of it, elements of the list or keys and values in the dictionary. And this is the recursive part. This is, again, basically like sub-agents in an agentic loop, in that every time the main top level LLM comes back with a code snippet, you will hand it off to a sub-agent to execute the code snippet, again, using your huge context as simply a variable, and give the results back to the top level model. If this sounds very much like Claude Code or Codex or any agentic coding agent, that's because I think it is. Here's their pseudocode for this agentic loop. So you initialize the REPL. The entire prompt is simply a variable. You initialize the history of your conversation, and then you kick off the LLM and you pass the state and the code that you get back from the LLM. You evaluate that. So the LLM is asked to come back with some code to peek and poke at this prompt, and you then evaluate that code and basically loop over it. Now, this initial system prompt is what sets up this entire thing. So let's look at that. Here's the system prompt, and they also have a GitHub repo, so I'll link to that in the description where you can get the code to run this and see the full prompt. And like I said, it prompts the top level model saying you can access, transform, and analyze this context interactively in a REPL environment. So you're not putting the entire context into the context window because it's larger than the window. That's the whole point. Context variable that contains extremely important information about your query, and it's given a tool to set off other LLM queries as well. That's the recursive part. Make sure to explicitly look through the entire context in REPL before answering your query. So this is basically telling the LLM, look, you can't literally look at the entire context in the window, but you can write code to treat it as a variable in code and peek and poke inside that variable, whether it's a very long string or a dict or a list. And there's some instructions about how to write out Python code so that it can be extracted and then evaluated by the agentic loop. And this is interesting because here they have some common patterns in the types of code that LLMs write to examine this very large context. As I say, we frequently observed models filtering and interacting with the context through regular expression code. They can effectively decompose their context through recursive subcalls. They're able to solve subproblems using recursive submodel calls and stitch their outputs to form a final output. So this sounds very much like what the cutting edge coding agents do today, agents like Claude Code or Codex and so on. And you can see how it's writing code to find snippets. Let's scan the context for clues using keyword searches or breaking up a very long context into batches. So it's doing a sliding window over the context and so on. And in their benchmarks, they did get it to scale. For example, one benchmark is what they call scalable needle in a haystack. So you have some very, very long context, huge chunk of text, and the query is to find one particular fact from somewhere in the middle of this text. So that's the needle in a haystack part. Now, obviously, if you want to compare with existing models like GPT-5, you can only go up to the context window length of GPT-5, and beyond that, you can't compare with the base model because it's beyond its context window limit. But as you can see over here, the performance of just vanilla GPT-5 degrades as you get close to its context window limit. Whereas, at least with the scalable needle in a haystack, the RLM system achieves a perfect score or a much higher score, both as you get to the limit and also as you go past the limit of the underlying model. And here you can see some more detailed benchmarks. BrowseComp Plus is basically concatenating a lot of web pages and then asking factual questions about that collection. And this gets up into the 10 million token range. OO-long is a benchmark that isn't about finding a needle or finding a specific fact or set of facts in very long context. It's more about understanding the entire piece. So you have to find things and synthesize and understand and summarize the entire context. And the pairs version of OO-long is even harder because it asks about relationships between two things in this very large context. And as you can see, the base models, even if you use GPT-5, really struggle with these harder benchmarks, whereas RLM comes out much further ahead. And the same thing holds even for smaller open source models. Even if you look at 8B models, you can see how RLM with even these tiny models produces much better scores. One way to interpret this setup and the effectiveness of it is that it's basically saying the models are getting really good at reasoning and coding. And those two things are just such fundamental leveraged capabilities that you can use them to solve larger and larger other problems. And as they say over here, models without coding capabilities struggle as RLMs. And that's pretty obvious because they're using coding as a way to deconstruct and peek and poke inside this very large context variable. Thinking models without sufficient output tokens struggle as RLMs. And here I think they're using output tokens as a proxy for how capable they are of thinking, how long the thinking traces can get. For example, if you've used GPT-5 Pro with OpenAI, where on some questions it can go for half an hour or even hours, the thinking traces get very, very long, sometimes much, much longer than the actual answer itself. So this is a proxy for just how much thinking or how long can a model go while thinking coherently. So if you have a good coding model with very good thinking capabilities, you can leverage it to not be limited by a context window size. And I think we've already seen a proof of that with coding models like Claude Code and Codex because they seem to be really effective even working in repos that are much, much larger than the underlying model's context windows. All right, so that was a quick look at recursive language models, cool technique to use reasoning and coding to break past the context window limits of frontier models. I hope you enjoyed that. If you like content like this, consider subscribing, like the video, and I will see you next time. Thank you.